I think this is a fairly challenging example of working on a circle and looking at the angles between things in degrees. So find two times between 10 p.m. and 11 p.m. when the hour hand and the minute hand of a clock are perpendicular. So the hour hand, it might start at 10 o'clock. Typically, that's the shorter, fatter hand, right? And it'll go to 11 o'clock as the minute hand, the longer hand. It starts at 10 o'clock, it's there. It makes one full revolution by 11 o'clock. So you could look at the angle between those two hands at any point, okay? So probably what would be most natural when I started this problem is to just sort of look at a number of examples of what's going on. Okay, so let's sort of start at 10 o'clock. Maybe I'll make a little table. When at, let's say, 0 minutes have gone by at 10 o'clock, we'll call it the shorthand or the hour hand, okay? Minute and minute. Maybe we ought to call it the shorthand. S for the shorthand starts out at some angle. Now, typically we measure angles starting at the positive right x-axis, so this would be 0, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees. So you might say, okay, the shorthand starts at 150 degrees. The long hand starts at 90 degrees. And the difference between them is kind of what I care about, right? I want the difference between them to be 90 degrees. Well, right now it's 60 degrees. But the minute hand's going faster, so you expect this difference to increase. So how much does it increase? Well, let's see. So every 5 minutes, what's going to happen? I guess the long hand, the minute hand increases by 30 degrees, right? The short hand, this hand right here, how do you think about that? Well, I guess I could think the short hand goes 30 degrees in 60 minutes. So how much does it go per minute? Let's see. So it's sort of 1/2 degree per minute, right? So in 5 minutes, I guess it goes 2.5 degrees. Notice this is somehow decreasing because we're going clockwise. So 5 minutes in, it's like at 147.5 degrees, right? And this one you could have done as a fraction also. It does 360 degrees. This is a rate, right? 360 degrees it turns in 60 minutes. And so you could reduce that to 6 degrees per minute, which indeed is what happened. 5 minutes went by and it moved 30 degrees, right? So at 5 minutes, it's 60 degrees, another 5 minutes at 30 degrees. Okay, so what's the difference between these now? This has increased by 30, the difference. This is decreased by 2.5. So that says we're at like 32, oops. The difference, I could use a calculator here, but the easy way, add 30 to make it 90, subtract 2.5. The difference between these is 87.5 degrees. They're pretty close to perpendicular. Notice if we went all the way to 10 minutes, and you could sort of eyeball this, right? That would be past perpendicular, past 90 degrees. This increases another 2.5 degrees, 0.5 degree per minute, 145. This decreases another 30 degrees. And now, let's see, we're at 115 degrees, if I'm calculating it right. So we're looking at sort of a sweet spot somehow between 10:05 and 10:10. Well, how do I do that more algebraically, right? I have these cool rates. I could actually come up with a formula for these things. The shorthand, the hour hand, starts at 150 and it changes at a rate. That's just sort of a linear function. So it's going clockwise, so we'll do minus 1/2 times the number of minutes. At 0, it's 150. At 5, it's 147.5, and so on. The long hand, the minute hand, starts at 90, and it decreases at a rate of 6 degrees per minute. And really what I'm looking for is I'm looking for when the shorthand minus the longhand is equal to 90. So short minus long equals 90. So let me just plug those in. 150 minus 1/2 m minus the quantity 90 minus 6m equals 90. Okay, so feels like we're going pretty well here. That's going to be where they're perpendicular. 150 minus 90 is 60. 1/2 minus -6 is 5.5 m. 90, subtract the 90, 5.5 minutes is equal to 30. So m equals 30 over 5.5, which is approximately, let's see, we've got 30 divided by 5.5, approximately 5.4545 minutes. 45 minutes. So at approximately 10:05.45. That's one time when they're perpendicular. And you could probably convince yourself at 10:05 and a little bit, we've got perpendicular clocks. Now the other time that's going to be perpendicular, this hand is going to race all the way around here, and then because this is getting more and more negative with my current formula, even though it's somehow a difference of 90 here, this one's still positive, this one's negative. So let me just say S minus L has now become 270 because that's negative. I'm measuring that piece. And let's do the whole calculation again. S, again, moving up to here, is 150 minus 1/2 m minus 90 minus 6m equals 270. Doing the subtraction here, I get, 60 plus 5.5 equals 270. Subtract the 60, 5.5 is m, right? That difference was an m, equals 210 degrees. So m equals 210 over 5.5. How many minutes have gone by with that? Well, let's see, 210 divided by 5.5 is 38.1818. So, and 10:38.18. Have a look at a clock, and those will be the times the hands are perpendicular.